Everything in our world moves. Ships sail on oceans, planes glide through the air, and cars drive on the road. Even atoms constantly move in some direction. Today, we will be studying motion using math. Mathematicians usually use three functions to help them determine motion. These functions are all used in relation to time: x of t for displacement, v of t for velocity, which is the derivative of displacement, and a of t for acceleration, which is the derivative of velocity. We will take a look at these functions for the use of a car. Sally wants to drive from Emsville to Edenbury. At the moment, she is somewhere halfway between the two cities. This point will be the origin for our displacement function. If she travels forwards, x of t becomes positive, and if she travels backwards, displacement becomes negative. However, no matter what direction she travels in, her distance traveled will always stay positive. Distance traveled is represented by the odometer. Let us say Sally is driving on a side street and her velocity would be positive, 35 miles per hour. However, when she sees a restaurant, she decides to make a U-turn and eat at the restaurant. Now that she is moving backwards toward her point of origin, she is driving at a velocity of negative 35 miles per hour. However, she is still moving at the speed of 35 miles per hour. The speed of the car is the absolute value of its velocity. Just like distance, speed cannot be negative. In fact, you can use calculus to find distance by integrating speed. Sally has finished eating her food, but now she needs to cross a mountain to get to Edenbury. She decides to let go of the accelerator for a few seconds while traveling up the mountain. Gravity makes her car start to decelerate, but her velocity is still positive. Because her acceleration is negative and her velocity is positive, she begins to slow down. She quickly puts her foot on the accelerator again. Now her acceleration is positive and her velocity is positive, meaning that she is speeding up. However, had she continued to leave her foot off the accelerator, she would have come to a standstill on the mountain before starting to roll back down the mountain. This is when her velocity equals 0, and it moves from positive to negative. Her car would have continued to decelerate, and because her velocity was negative as well, she would be speeding up down the hill. Despite the rather simple implications shown here, there are far more important situations in which straight-line motion can be used. For example, through the creation of a y of t and z of t function for the displacement on the y and z axes, you'd be able to track an object's movement in a three-dimensional space, calculate the trajectory of comets, the paths of airplanes, and even the minuscule movements of atoms. The possibilities are truly endless.